Hello all, welcome back to my channel. I'm Amir, and in this particular video we'll be taking a look at the solution for problem number 83 of Leetcode, that is remove duplicates from sorted list. Well, without wasting any more time, let's jump right into the problem statement. Well, the problem statement is given the head of a sorted linked list, delete all duplicates such that each element appears only once, return the linked list sorted as well. We have a very simple example here. We have a linked list of three nodes which contains 1, 1 and 2. So you can see the number or the value 1 appears twice. So what we'll be doing is we'll be removing this particular node and we'll be connecting the first to the second node and we'll be returning this particular linked list. So as you can see here, we have a linked list of 6 nodes and each contains a value that is 1, 1, 2, 3, 3 and 5. Well, in this you can see the ones and threes are repeating. So we have to return a list which doesn't contains these repeating elements. This will be the end result of our operation. So let us take a look at how we'll be proceeding with the removing of this particular reoccurring or duplicate elements. So with this example list, you can see we'll be comparing this particular value with value at the next node. So we can see that the value 1 and 1 are appearing. If we confirm that the values are duplicates and are reoccurring, what we'll be doing is we'll be playing with the link of the another node. So we'll be breaking this particular link which is pointing to the next, that is the second node, and we'll be connecting it to the next node, right? So what will happen is we'll have a linked list which will be looking something like this. Once we are done, we'll be moving our pointers up here and we'll be comparing 2 with 3. Since they're unique, we won't be touching this particular link, it will stay as it is. And now we'll be comparing 3 with 3. As you can see, the values are reappearing again. So what we have to do again is we have to break this particular link and we have to connect it to the next of the next node, that is 5. So our linked list will look something like this. So this should be our end result. Now let us look at the approach itself. So what we'll be doing here is we'll be using nested while loop. So the first while loop will be traversing through the linked list, that is from the start to the end, while the another while loop, which would be the inner loop, is responsible to traverse through the nodes, compare the elements and remove the duplicate elements. So now that we have a very naive idea, a bird's eye view of how we'll be proceeding with this particular solution, let's get into the coding part itself. Now let us look at the code level implementation of this particular solution. So before proceeding into this problem statement, let me explain that we'll be using another linked list item. So why would we want to have another linked list item? Is very simple. It is to preserve the position of the head so that we'll just return the head itself. So saying that, first I'll create another item of another object of type link list node and I'll name it as current. And this will be pointing towards the head itself. And remember, previously I said that we'll be using two while loop. One is to iterate or parse through the linked list, right? So we'll be using the outer loop and this loop will run up until we reach the end of the linked list. So what would be the end of the linked list? That would be the null pointer. So up until current is not equal to null pointer. Next, once we start traversing the linked list, now we have to compare the nodes inside the linked list which have similar value, that is repeating value, and we have to cut that particular linked list sequence and connect it to the next node of the linked list, right? So what we'll be doing is we'll be running another while loop and the conditions here is we'll be using AND operator which will be comparing two values. First is the next node to the current node must exist. So current of next must exist and the value at current node must be equal to the value to the next node, right? So current value must be equal to value node next to the current node and its value, it's val. Then what we'll be doing is we'll be breaking the chain and we'll be pointing the current node to the next node. So it will become current next would become current next to next, right? Once we're done with this, we'll be moving the current node to the next node. Once we are done with this, we'll be returning the head itself. As you can see, it has run without any compilation error, and I'll be submitting this particular code. Upon submission, it has passed all the test cases and we have successfully submitted a solution to the particular problem. So the fundamental concept here is very simple. We'll parse through the list, we'll compare two nodes, and if they are similar, we'll break their chain and we'll be pointing the current node's next position to the next node from the current position. So that's all for this particular video. See you in another one. Bye bye.